Okay, so welcome back. The main focus of today is going to be on research areas, which we have an amazing guest speaker to talk about. But before we dive into that, by popular demand, there was a request to talk a little bit about machine learning teams. And so I'm just going to spend a few minutes on that. And one of the focuses of this lecture is on kind of what are our jobs like in this field and what does hiring look like. So can I just get a quick sense, show of hands, like how many people are interested in some way or another and looking at a job in machine learning engineering at some point, next year, next 6 months? Okay, so a good number. One thing we're thinking about doing is bringing in some industry people who are looking to hire people to the project presentations at the end of class to just give kind of short presentations on what they do and what they're looking for in people on their teams. How many people would be kind of interested in hearing those presentations if we did that? Talking about machine learning teams, and there's a few topics I want to cover. The first is just what's the context that we're working in here, and so and the context is mostly defined by the gap in AI talent. And then I'll talk about the different roles related to machine learning that we see in industry often. Then I'll talk a little bit about like how those roles are typically formed into teams, and then what the hiring process often looks like. So the AI talent gap. One question you might ask is, how many people are there out there that know how to build sort of high quality AI systems? And there are different estimates that you can find of this. One estimate, the lowest estimate that I found was 5,000. And so that's people who are actively publishing research according to Element AI. So that's kind of like a lower bound on the number. From the same report, the people with the right skill set, whether or not they're publishing, is more like 10,000. Bloomberg estimated that there are more like 20,000 PhD educated AI researchers. Now, not everyone working in AI needs to have a PhD, obviously. And so, you can think about what's an upper bound on that number. And Element estimated at 90,000. And a different report estimated at around 200,000. But the point I want to make here is that comparing this to the numbers for a more mature industry like software development, that's more like 3.6 million people, right? So there's still a huge gap, a huge difference between the number of people that know how to do AI and the people that know how to do software development. And that number is even bigger if you look at the entire world. So what is the implication of this, right? Like, what does the shortage in AI developers mean for AI hiring? In short, it comes down to a fierce competition for AI talent. And this is a quote from Bloomberg. Everyone agrees that the competition to hire people who know how to build artificial intelligence systems is intense. It's turned academic conferences into frenzied meat markets for corporate recruiters and driven the salaries of top researchers to 7 figures. Right? And for those of you who have been to machine learning conferences in the last couple of years, I think you would agree that it's like there's very much a feel of like massive competition to get the top people. So we talked to a couple of people who were kind of running startups and hiring for them in the process of making the full stack deep learning class that we did. And a couple of quotes that stood out to me from a computer vision engineer at sort of a late stage startup. Hiring is crazy. ML got popular really quickly. There's a ton of demand and not a lot of supply. Hiring for ML is really challenging, takes way more time and effort than we were expecting. We're only able to get a few people per quarter despite our best efforts. And this is just kind of the general story that we heard from most startup founders and people in big companies that we talk to. It's just really, really hard to hire for these positions. So what are these positions? The most common roles at companies that we see that involve machine learning are sort of DevOps engineers, data engineers, ML researchers, and data scientists, right? So these are all like these buzzword terms. And what is the difference between these? Like, what do these actually mean in practice? And so you can break down each of these jobs by sort of what the role that they typically play in teams are. So DevOps engineers, their job is really deploying and monitoring production systems. And so what they're producing, like what their work product is a deployed product. So something that's actually on your phone or on your computer and is being served to end customers. And so they're using tools like AWS to actually serve predictions. Data engineers are typically focused on building data pipelines. So collecting data, figuring out how to store it, figuring out how to monitor it, figuring out how to serve it to machine learning workflows. And their work product typically looks like a Hadoop distributed system or something like that. Next, we have ML engineers, and their goal, like this is sort of a pretty broad role, and what they're tasked with is most often training and deploying prediction models. So their goal is like often they're given a data set, and what they're trying to do is produce a system that can create predictions and then either deploy it themselves or hand it off to someone like a DevOps engineer to deploy it for them. And so these are people who are working in TensorFlow, but then also tools like Docker, because they're often pretty close to the actual deployment. Then you have ML researchers, and there's sort of a fuzzy line between ML researchers and ML engineers. But ML researchers, the biggest difference is that often the prediction models that they're training are not production critical, or they're not production critical in the short term. But they're often working on sort of more speculative products or projects rather that could make it into the product at some point, but are not going to be deployed tomorrow. And often the work product for these folks looks like actually a report that describes what they tried and what the results look like, and that might get picked up by the rest of the team to deploy. And then you have data scientists. And the tricky thing about data scientists is that this is really a catch-all term that can mean many different things in different organizations. And so I've heard this used to describe any of their roles above. And in some organizations, in many organizations, in fact, data scientists are actually not doing much machine learning at all. It's more of an analytics role. And so this can mean many different things. And so what you might ask yourself if you're on the job market or if you're hiring for these roles is, what skills do you need in order to succeed? And so on this chart, we have sort of the level of machine learning skill that you need on the bottom and the level of software engineering skill that you need on the left side. And the size of the bubble corresponds to how good you are at communicating and technical writing. So how good you are at sort of convincing the organization of your results. So talking about each of these individually, ML DevOps, high on software engineering, relatively low on machine learning. This is primarily a software engineering role, and oftentimes these folks don't have any machine learning background at all, or are sort of in the process of learning machine learning, and want to work closely with an ML team, but their skill set is more on the software engineering side. Data engineer is pretty similar, mostly software engineering, but there's often a slightly higher requirement for ML knowledge because their work product is so closely tied to what the machine learning team is actually using. ML engineers, this is sort of, I think, like kind of one of the unicorn skill sets from a lot of companies that we talk to. A lot of people said that this skill set is particularly hard to hire for because it requires sort of a rare mix of machine learning skills, knowledge of algorithms, but then also software engineering skills. And so if you're kind of if you're a really good software engineer and you're also sort of pretty far along in your learning of machine learning, this can be a really interesting role to go for. ML researchers, this is your ML experts. This is kind of the one role where still see most people have sort of a master's degree or a PhD in CS or stats, or did something like the Google Brain residency. But I think this is starting to change. But of all of these, this is the one where kind of academic background still matters the most. And then data scientists, again, since this is kind of a catch-all term, it corresponds to a pretty wide range of backgrounds. One common background that I've seen is for people who have some other sort of science PhD, like maybe they did a PhD in chemistry or something like that, and they want to move into the tech world. This is kind of a common role that people with that background go into. Okay, any questions about kind of the landscape of the roles and the skill sets that you need for those roles? All right. The next thing I want to talk about is like, how does this all fit together into teams? So what do teams look like that are working on machine learning projects? And the main thing that we learned when we talked to a bunch of people about how they're organizing their teams is that there isn't really a consensus yet on the right way to structure a team that's working on machine learning projects. But there are some lessons that we learned that I think are worth sharing. So the first thing is that a lot of the people that we talked to mentioned that it's really important to not just have ML teams that only know machine learning. Like if they're working on stuff that's going to be deployed into production, almost everyone thinks that it's very critical to have software engineering skills on the team. Where people didn't agree is whether that can be a mix of people who are really deep in machine learning and really deep in software engineering, or whether everyone on the team needs to have a mix of both skill sets. We talked to people who have both of those views. Different teams had a different view of machine learning researchers. So we talked to some people who said, yeah, machine learning research is exciting, but I don't really like to hire machine learning researchers because it's just too hard to integrate them with my software team and my product team. And so I don't actually get useful work out of them. Other people who maybe are working on more frontier technology think that it's actually really critical to have at least one or two people on the team who have deep ML expertise because the field is moving so fast. You need people who can keep up with it and make sure that you're always doing things that are up to date. There were also differing views on data engineering. And so this kind of tends to sit in different places within the organization. In some organizations, it sits within the ML team. And so the rationale there is, the output of this team is the input for the machine learning team. And so these two functions should be as close together as possible, right? Like the data team's work product is directly used by the ML team, and so they should be, their desks should be next to each other. Other organizations have it as a separate team, which is often called data warehousing. And then another thing to note is that a lot of organizations that we talk to think that it's important to have people who are dedicated to data labeling. And this doesn't necessarily mean people who are labeling data themselves. It could just be people who are managing the outsourced data labeling workflow, because it's such a critical part of what the ML team needs in order to do their job well. All right, I want to say a few words about managing machine learning teams. And the point that I want to make here is just to point out some of the challenges of why this is often more difficult than managing typical software teams. And I don't really have all the answers here, but I think it's helpful to sort of understand why this is a particularly difficult problem. And so the first reason is it can be really hard to tell in advance, for this particular problem that you want to work on, is this a really hard problem or is this a really easy problem? And I imagine some of you are maybe feeling this way about your projects right now. Some nods, yeah? Okay. I like these charts that Lucas already showed you, but this is from I think it was a Kaggle competition that he ran, where they looked at accuracy of a model on some data set, and they looked at how performance was improving in the first week. And it's like, great, accuracy's gone up from 35% to 70% in a week. It looks like this problem is just going to be solved in the next couple of weeks. But then when they looked at performance throughout the 3 months of the project, it turns out that this this really fast growth at the beginning was actually just ramping up to a plateau, and the accuracy didn't actually really improve that much beyond that. Despite the fact that the amount of effort going into it was increasing dramatically. Right, so you might have seen this first chart in the first week and thought, hey, this is a pretty easy problem, and we can, we don't really need to staff up this team too much. It's just going to be solved in the next couple weeks, and then been disappointed 3 months later. So it's a tricky situation as a manager. A related problem, I think, is that machine learning projects and the progress on them tend to be very nonlinear. And so this is like kind of in stark contrast to software engineering projects, right, where you can generally tell on a week-to-week basis, have a reasonable estimate of how much work you can expect to get done. But in machine learning, projects often stall for weeks. And And it's often kind of very unclear exactly what things you're going to need to try because you haven't hit the roadblocks yet. So it can be difficult to parallelize things and estimate project timelines in the early stages of the project because you kind of need to just start trying things and see what works before you know exactly what you're going to need to invest in. And so one way I like to think about this is, even in applied machine learning and machine learning that's going into production, it's still not, like, in my opinion, totally an engineering discipline. It's still somewhere in between research and engineering. Another common issue that we've seen in talking to companies about this is that there's often a cultural gap between people who, whose background is research and people whose background is engineering. And this can manifest itself in different ways, just from sort of different values, different kind of outcomes of projects that they care about, different things they're excited about working on. And in like the worst examples of this, what this can look like is either side thinking they're better than the other. Like research thinking, oh, we're the ones who are working on the really challenging part of this problem, or engineering thinking like, oh, we're the ones that are actually building things that are useful. And so this is a problem that crops up in some organizations, and it takes conscious effort in order to make sure it doesn't happen. And then the last thing I'll point out is that we've heard from a lot of people actually is that leaders just often in your organization often just don't get machine learning, and I think this can manifest itself in them like kind of not understanding the difficulties that are listed above. But this is a challenge that a lot of people who are trying to start machine learning efforts within larger organizations complain about. And so I think it's just important to make sure that leadership understands why the problems that you're working on are kind of uniquely challenging. All right. Any questions about machine learning teams, managing them? I think I've like pointed out problems here, but not suggested solutions. So also, if you have any solutions, I'd love to hear them. Yeah.
It's not a solution, just a question. Could you expand a little bit more about what software engineering skills can particularly be useful in a machine learning project? Because I think for me personally, like trying to learn, there are limited resources on how you should sort of do your machine learning project and how you should do unit testing. And there isn't like a standardized gold standard to
yeah. I think a lot of much of the standard software engineering tool set is helpful. Like I think most machine learning teams are doing a lot of building their own tools. And there are companies out there that are trying to make sure that this doesn't happen anymore. But the current state is many people are still doing this. And so if you're good at building tools that can be used by machine learning engineers or machine learning researchers, that skill will come in handy. I think the other big thing is like sort of distributed systems broadly, like being able to parallelize workflows and parallelize sort of data pipelines and things like that is just like really deeply useful. That's like the one particular thing I think that people look for. Anyone manage a machine learning team? Yeah. How do you deal with these problems? Like have you seen these? Yeah.
It's like very small things that trying to figure out a way.
Sorry?
We're trying to figure out ways to deal with it.
Yeah. Is there anything in your experience that's been particularly useful?
Finding people can help with the machine learning pipeline is very hard. So people can just do like creating a very reliable machine learning pipeline.
Yeah.
For us, it was more like finding a champion, especially the business side, who can actually understand not necessarily everything with respect to machine learning, but at least the use cases and the pain points, and evangelizing that to the business is really helpful.
So finding someone who can bridge the gap between the technical work and then the business outcomes that you're trying to get to. How did you find that person?
We were lucky that there was one guy who moved from the technical side of machine learning into business side. And then we had a couple of business leaders who were actually much more lenient towards the data problems and the data use cases.
Got it. So there's so you found someone who understood the technical challenges from previous life and then was willing to sort of translate that. Yeah.
Storytelling and explaining things is one of the key points that we felt made a difference for us.
And then are there differences between how you think that works, how to tell a good story about a machine learning project versus a general software engineering project?
No, we didn't find that much of a difference in there.
Yeah.
But you just need to be good at communication to make sure. Because many of these problems, when we say that, hey, for us, the practical issue was when the prediction is telling something else, but the common sense is completely opposite of that. So it was hard for us to convince our sales team and marketing team that they go with what we are telling you.
Convincing them to trust the system.
Yeah.
Yeah. Any other thoughts on this part? I think this is like sort of one of the hardest challenges in building machine learning products right now. Yeah.
Can you speak to like project management of these types of projects? So I'm a data scientist and I feel like it's really hard to like make tickets in a classic Jira style. Have you worked in any project management style for a machine learning project that's been helpful?
Yeah. We've tried a lot of things at OpenAI. And what's tended to work best is just kind of like the simplest and lightest weight things, like even just a Google Doc where people sort of talk about what they're planning to work on in like on the time frame of say a week, and then check in after a week to see how things go. One of the challenges is that I think in a lot of people who come from software engineering backgrounds kind of expect if you said you're going to get something done this week, then it's going to get done this week. And it doesn't, at least in my experience, has not always worked out that way for machine learning teams because, often the thing that you tried doesn't work, or you encounter some difficulty in implementing the thing that you didn't foresee when you decided to work on it. And so I think one thing that's like one mindset that's been helpful has been to think about measuring people's sort of inputs as opposed to their outputs. So I think a big driver of how much progress machine learning organizations are able to make is just how many ideas they're able to try, right? Because every idea has like some probability of success, and like even the most brilliant machine learning researchers like are only right, I don't know, 50% of the time. Maybe that's generous? Probably less. Yeah. And so if you're able to try 10 things in the time frame that it takes someone else to try 2 or 3, then that's a huge advantage. Yeah.
Kind of going off of that, how do you, with teams that you work on, like how do you do like metrics for like researchers, or like what are the things like performance, like what does it mean to like be a good researcher on a team? Like one thing is like number of ideas you try, but are there other things?
Yeah. So number of ideas that you tried, I think, is a really important one. I think there's some time scale, like under which you have to sort of be able to make things work. And I think it depends a little bit on the context of the organization, how long that is. Like I think in most organizations, if a researcher, for example, has not tried any ideas that have worked over the course of a couple of years, then it seems like that's probably bad. But maybe if it's 3 months, then it's like it's pretty reasonable to not have any ideas that have worked in that time frame. Another thing I think that's important is just like how well they're able to sort of connect their ideas to the rest of the team in the organization. So like I think one failure mode for integrating researchers with broader teams is that they kind of work on their own things, and even their best ideas never really make it back into the work that the rest of the team is doing. So I think having metrics around that could be valuable as well. Great. The last thing I want to talk about a little bit is just ML hiring. So a lot of you are thinking about looking for jobs in the next year or so. Some of you maybe are looking to hire people. So I think a lot of the places to look for ML and data science jobs are just the typical things that you would think of. So applying directly to companies you're interested in. I think a lot of people in general think that this doesn't work. One thing that I've noticed is that in machine learning, since these roles are so hard to hire for, sort of the direct approach can actually work quite well. if you're in school, on-campus recruiting, if you're more experienced, LinkedIn recruiters, ML conferences are great places to go look for jobs. A lot of the big companies are there kind of with booths, and they're very actively hiring at those events. And then lastly, as I mentioned, we're going to bring in some folks to do some who are looking to recruit in the project presentations at the end of the class. So connecting with those people could be helpful. So what should you expect in the interview process? I feel like software engineering interviews are sort of very well defined at this point, and you can kind of buy a book that tells you what types of interview questions to prepare for, and you can Google interview questions and you can figure out exactly the right way to solve them. The interview process for machine learning roles is much less well defined at this point. There's a lot of types of assessments that are pretty common, but they are mixed and matched in different ways. Here are some of them. I think the first few of these are, let's see, the first 3 of these are just sort of general software engineering interview type questions that you might get. In terms of ML specific stuff, a couple things that I've seen that are interesting, pair debugging on ML specific code. So sort of like the debugging exercise that we did a few weeks ago. It's like, hey, here's some buggy code. Let's sit down together and figure out where the bugs are. You see a lot of math puzzles, a lot of linear algebra puzzles. Take-home ML projects, like here's a data set. How well can you do on this data set? Those are pretty common. Apply to ML. So, here's a problem that, like maybe one that's related to what the team is working on. Tell us how you'd approach solving it. What data would you be looking for? What type of model would you train? It's a very common type of question. People also often like to try to dive deep into your previous ML projects and sort of probe at the assumptions you made and why you made certain decisions about what architecture you chose, or what your goals were for the project and things like that. And then ML theory questions are also very common. So, explain the bias variance trade-off. What's the difference between overfitting and underfitting? How do you know whether you're overfitting or underfitting? Asking you to explain specific algorithms that you're familiar with. In terms of how to prepare, I think it's especially, this advice is kind of focused on the machine learning engineer role. I think it's still very important to prepare for a general software engineering interview, because it seems like a lot of companies will ask those types of questions. Make sure that you are sort of brushed up and ready to talk about previous ML projects that you've worked on. And then I think the rest of it is around reviewing the basics. So make sure that you remember how kind of like even simpler machine learning algorithms work, like linear regression, nearest neighbor, things like that, and you can explain it to someone. And then if you're interviewing in a company that does a lot of deep learning, then reviewing the Ian Goodfellow's deep learning book is another really good way to just make sure that you've covered most of the basics. Great. Any other questions on hiring, jobs, teams? Yeah.
Sorry, what was that book you said?
Ian Goodfellow's deep learning book.
You can also Slack it out later.
Oh, yeah, I can Slack it out. If you Google deep learning book, it's also the one that comes up. Yeah. All right, so that's all that I wanted to cover. In terms of homework for next week, there's a lecture that we want you to watch, and I'll post a link to this in Slack on testing ML code bases and deploying machine learning systems. And then the other piece is just continuing to work on your projects. And again, feel free to post updates and ask questions. I'm happy to kind of go through those and make specific suggestions on places you get stuck. I think we have 2 weeks left in the course. And so, if you're at the point where you're getting close to having something that you feel like is working but is not quite there, then that seems like right where you should be. But this is a good time to make like a final push to have something that's working pretty well for next week, so you can kind of wrap it up and make a good presentation the following week.